This is Chapter 7, Lecture 1, Sedimentary Environments and Rocks. Our goals for this chapter include an introduction to weathering as the source of sediment or clasts. We will become familiar with sedimentary environments and their associated deposits and rocks. We'll investigate how geologists study sedimentary rocks, infer sedimentary environments, and reconstruct changes in past environments. We'll look at this landscape with Vancouver, British Columbia, and consider where erosion, transport, and deposition of sediment might occur near the Fraser River of Canada. So this is the coastal range and Fraser River Valley of southwestern British Columbia. You have mountains eroded by glaciers and lakes in the valleys. Sediment is carried by rivers to the ocean as well. And it's actually light blue as it enters the water. So that's sediment-rich water. And this is the area where cities are located. So you have Vancouver, Bellingham, Washington, and other cities in this environment. And Vancouver is built on the older part of a river delta, not unlike Bay City, is in proximity to the Saginaw River Delta. And this close-up shows the Fraser River with multiple channels. That's a braided stream. So the mountains are really our main source of sediment, and it transports to areas of lower elevation until it reaches a larger body of water in the Strait of Georgia. We'll look at these land environments generically and consider the kind of sediment present at each part. So mountains, you might find angular sediment because it's close to the source as it's broken apart. Sediments from glaciers, you can have all different sizes of sediment from very large to very fine and powdery. A steep stream or river will have what comes out of the mountains. Sand dunes will have mostly sand-sized sediments. And then a gentle meandering river, you can expect smaller sediments. A delta is going to have a combination of really fine sediment and larger sediment. And then lakes, generally fine sediment. Same thing with wetlands. Okay, so I'll show you pictures of that. See if I got it right. Angular sediment from the mountains. A huge variety in sediment sizes from glaciers as well. This is in the French Alps. Now a steep braided stream. They become braided when they're less confined by, say, bedrock. They can move boulders and round material over time. This is Denali Park in Alaska. And sand dunes forming in dry climates. They usually have sand-sized grains of quartz in general. We'll get to the rest of it with this slide. As I said previously, we have fine sediments in a floodplain along a meandering river with silt and clay. Deltas form where a river enters an ocean or lake, causing the flow of that river to slow down. Suddenly there's not enough energy for sediment to continue to be carried, so it is deposited. With lakes, we have deep water in the center and more active water along the shorelines due to friction. They can remain filled with water, or they can completely dry out. This is Lake Superior in Michigan. And here's wetlands as well in Florida. They contain abundant vegetation, which may become part of the sediment over time as it breaks down. So that's generally what you might see from those environments. Now, looking at shorelines, we can think about what might show up here in the beach, the reef, the lagoon, coastal dunes, tidal flats, and the delta. I'd consider probably broken shells, sandstone grains here. In the lagoon, finer sediment. In the reef, thinking about calcium carbonate, limestone, remains of coral, or shells from creatures. Tidal flat's going to have really fine sediment like mud. The delta will have some combination of fine sediments and larger sediments. And the offshore delta is going to have even finer materials because it takes more energy to transport that. Barrier island's going to have a combination. Deep sea floor should be pretty fine the further you go out. All right, let's see what that might look like. Beaches consist of sand, shell fragments, rounded gravels, cobbles, or boulders. Coastal dunes form where sand from the beach is blown or washed inland. Reefs form where ocean water is shallow, warm, and clear. And then lagoons are shallow, quiet areas sheltered by reefs or islands. So tidal flats are low areas flooded by sea during high tide, but exposed during low tide. So you see a lot of mud here. This is the Olympic Peninsula in Washington. Deltas can extend for many kilometers beneath the waters of the ocean. This is the Mississippi Delta in Louisiana. And deep oceans can accumulate thick sediment, which can collapse in landslides or turbidity currents. And those are turbulent flowing masses of sand, mud, and water. And it can also contain submarine canyons, like so. Okay, so making sediment. Let's talk about that in terms of physical weathering. You can make sediment through fracturing of rock. That's when rocks pull away from a steep cliff or when rocks expand as they are uplifted to the surface. You can make sediment from frost and mineral wedging. Frost wedging pries rocks apart as water in cracks freezes and expands. This also occurs when crystals grow within fractures, so that would be mineral wedging. With biologic activity such as root wedging, that would pry rocks apart when roots move through rock or when burrowing animals move rock and soil from the depth to the surface. And then thermal expansion, that's where extreme temperature changes causes rocks to contract and expand, and locally causes rocks to crack. All right, so making sediment with chemical weathering. You can have dissolution, which is a process where minerals are dissolved away, releasing ions that can be carried away in rivers, streams, or groundwater. Hydrolysis occurs when silicate minerals are exposed to water and natural acids, converting original materials to clay and removing positive ions. Oxidation involves minerals that combine with oxygen to form oxide minerals, such as iron oxides. You can see how this is sort of rust colored. And biologic reactions occur when decaying plants produce acids. And then bacteria can consume rocks. All right, so sediment or classed sizes. The sizes of class are used to classify loose sediment. Okay, so in general, you can have boulders, cobbles, pebbles. A boulder is like larger than 256 millimeters. A cobble is, say, 64 to 256 millimeters, and a pebble is between 4 and 64 millimeters. Sand can be coarse, medium, or fine, and that ranges with smallest as 1/16 of a millimeter to 2 millimeters in diameter. And then silt would be 1 256th of a millimeter to 1/16th of a millimeter, and clay is less than 1/256th of a millimeter, so it's extremely small. That's how we can talk about different sediment sizes based on that classification system. We can also look at the shape of sediment. So this is angular. This is what we call partially rounded. It's kind of in between rounded, which is down here, and angular. Angular, partially rounded, rounded. And the range of different classed sizes is called sorting. If there's a huge range in size, we say that something is poorly sorted. The sediment is poorly sorted because we have large sizes and we have small sizes and we have in-between sizes of sediment. So it's poorly sorted. They're not all the same. If the sizes are a little closer to one another, we'll say it's moderately sorted. And if they're all the same size, we're going to say that's well sorted. They're all of the same kind. And that's one way to describe what we see. So what controls size, shape, and sorting of sediment? As you go further away from the source of rock, you get rounder and smaller sediment. Steep slopes contain sediment that's poorly sorted and angular to start. But then with strong turbulent rivers and ocean waves, you can move large clasts over time. And less turbulent currents can only move really fine-grained sediment. They have less energy. The agent of transport, whether it's water, wind, or ice, is important because it constrains the size of the sediment that can be moved. For example, wind can only move fine particles, but glaciers can move large and small particles. So common clastic sedimentary rocks. One would be conglomerate. That's rounded to partly rounded pebbles, cobbles, or boulders, usually with sand and other fine sediment between larger clasts. Breccia, that has angular pebbles, cobbles, or boulders with finer material in between, holding it together. And then sandstone, you have sand grains composed of quartz, feldspar, or other minerals. And then shale, that's compacted clay minerals. Those are all pretty commonly found. So how does clastic sediment become rock? Well, you have compaction of sand and grains. So sand grains rest on one another, but they don't fit together tightly. If they're compacted, the grains nestle together and space decreases. With compaction of clay particles, those at first rest at various orientations with a lot of open space. But once compacted, they line up and the open space decreases significantly. With cementation, open spaces between grains allow mineral-rich water to flow through and deposit minerals, which then binds the grains together and it makes the sediment harder. Some common cements would be calcite, quartz, and hematite. Looking at rocks formed by chemical reaction, we have rock salt here, sodium chloride. That forms when oceans and lakes containing sodium, calcium, and chloride evaporate. So a setting like this. There's also travertine, which is a type of limestone. It forms as chemical-rich waters precipitate calcite, such as from temperature changes or when two different types of water mix. So it could be from a setting like this with a waterfall. Rocks formed by living things include limestones with fossils. Coral and microscopic organisms use calcium to form shells, and when cemented together, they form a rock called limestone. The setting would be like a reef where it gets plenty of sunlight because it's still shallow. coal as well. It's formed from plant debris in wetlands and bogs. It's formed from that when those plants die and decay and compact into an organic, rich sedimentary rock. So the setting looks something like this, like a wetland. Other non-clastic sedimentary rocks include gypsum, chalk, dolostone, and chert. And gypsum forms mostly as seawater evaporates in a tidal flat or in a narrow sea. It also forms in drying lakes. Chalk is a type of limestone formed by the accumulation of microscopic organisms that float in the sea. And dolostone forms when calcium in limestone is replaced by magnesium, so it becomes calcium magnesium carbonate. Chert forms in a variety of ways. One way would be the compaction of tiny silica-rich plankton that fall to the ocean bottom, and it can form by replacement when different waters mix together. We'll look at different characteristics of layers in sedimentary rocks. Starting off, we have thick layers in Arizona, thin layers in northwestern New Mexico, gradational boundaries, like these sort of change in Colorado, and then a sharp and abrupt boundary and change in rocks from Southern California. These are just examples. Sedimentary rocks can form beds. These beds are parallel. That's one layer on top of another. Cross bedding, that's what's preserved when sediment is deposited from this side and rolls down the other side on the leeward side. That can form from sand dunes moving over time. Graded bedding, you've got coarser material at the bottom of the bed followed by successively finer sediment. So, yeah, you can have different orientations formed without any sort of tilting due to plate tectonics. We'll look at breccia now. Now, breccia contains a wide range of classed sizes. We can say it's poorly sorted. It's a breccia with a rocky matrix or with a muddy matrix. It can form near a steep mountain front. Landslides form from landslides, alluvial fans, debris flows, and glaciers. So we see this as an example, and we see the debris flow that can later be lithified into breccia. Looking at conglomerate, that contains moderate to well-rounded clasts, not angular like breccia, including pebbles, cobbles, or boulders, with usually a finer matrix. It can form in rivers and streams, and braided rivers, and on alluvial plains from that, beaches, deltas, and turbidity currents. We'll look now at sandstone. It can form in a variety of environments, including sand dunes, rivers, floodplains, beaches, turbidity currents, etc. Just wherever you have sand-sized grains. So, most beaches consist of sand with shells, pebbles, or larger blocks of rock derived from nearby sources. Sand in deltas is usually accompanied by shale layers and organic rich layers, like coal. Continental shelves and deep interior seas contain sand derived from land. Sand can be transported into the deeper ocean by turbidity currents. And we'll stop here for today.